All right, concept 25 is binomial expansion, and we're starting here with just finding one of the terms of this expansion. So we know in our answer there's going to be three parts to the answer. There's going to be the coefficient in front, there's going to be the first term, and then the second term. So let's start by filling in the terms that are here. This is going to be the first term, this is going to be the second term. We still need to find the coefficient, so we'll do that in a minute. The x, or the first term that's here, we know when we do a complete binomial expansion that the exponent starts at the value that we have in the original problem and decreases. So if we're on the third term, and I'm just gonna count on my fingers here. The first term is gonna be a 3, the second term would be a 2, the third term would be a 1. So I know here that my exponent here is a 1 because I'm on the third term. 3, 2, and then 1. If this is a 1, these exponents need to add up to 3, so this must be a 2. And now for the coefficient, it looks like the combinations formula. You just take the total exponent factorial, and then each of these exponents factorial. So let's simplify this. 3 factorial over 1 factorial, 2 factorial is just equal to 3. We have an x to the first power, and we have a 16y squared. Don't forget to square the 4 and the y. So this totals to 48xy squared. How many terms are in the expansion? The exponent is 14. Every binomial expansion has a number of terms that is one more than the exponent that's given. So here we have 15 terms. And this last one, number 21, we're expanding this completely. And in order to do that, we need Pascal's triangle. So you should be able to recreate Pascal's triangle by adding the numbers above to give you this one. And all the sides of the triangle are 1s. We're looking for an exponent equal to 4. So this is n equals 0, this is n equals 1, n equals 2, n equals 3, and we need n equals 4. So let's just go up to 4. So 1, 4, 6, 4, 1. So these coefficients are going to be the coefficients of my answer. So I'm going to just line those up and leave some spaces between them for the two terms that are in my problem. So next to each coefficient, I'm going to put parentheses for both terms. And we're adding all of these terms together. All right, so if we set it up like that, we have our coefficients 1, 4, 6, 4, and 1, and we have parentheses here for each of the terms. The 3x, the first term, is going to go in all of these parentheses. And the second term, the negative 2, is going to go in all of these parentheses. Okay, the property we need to understand here is that the first term exponent is going to start at the value in the original problem, which is a 4, and keep decreasing until we get to the last term. The exponent of the other value, the second term, is going to start at 0 and increase all the way until we get to 4. Now the job is to just simplify each of these. Make sure you raise everything that's inside the parentheses to the exponent. So 3 to the 4th is 81, x to the 4th, this is equal to 1, this is equal to 1. Here we have a 4, we have a 27x cubed, and a negative 2. Here we have a 6 times a 9x squared times a positive 4. Here we have a 4, a 3x, and a negative 8. And the last term here, negative 2 to the 4th, is positive 16. So let's simplify this completely. We have 81x to the 4th. 27 times negative 2 is negative 54. Negative 54 times 4 is negative 216x cubed. 9 times 4 is 36. 36 times 6 is positive 216. Negative 24 times 4 is negative 96. And then we have a positive 16. You'll notice when you have a minus in your binomial expansion, the signs alternate. Positive, negative, positive, negative, positive.